Hello, Chem fans. It is time for us to talk about topic 7.10, reaction quotient and Le Chatelier's principle. So when we talk about equilibrium, we have established that the concentrations of all species in a reaction are equal to the ratio between the products and the reactants raised to their coefficient powers, which is called the equilibrium constant. And so if we have a reaction, substance A plus substance B, and these two substances react and set up an equilibrium to form substance C and substance D in solution, then the ratio of the concentrations of the products raised to their coefficient powers divided by the product of the concentrations of the reactants raised to their coefficient powers is equal to the equilibrium constant. So the reaction will proceed to the right, producing products, and the products will proceed to the left, producing reactants, until the ratio of the concentrations of these equal the experimentally determined equilibrium constant. And that's a very important part of this, is that equilibrium constants have to be experimentally determined. Um, they aren't something that can be intuited or obvious from a chemical reaction. And if you recall, we've talked about how if K is much greater than 1, then the reaction is product favored. And if the equilibrium constant is much less than 1, then it is reactant favored. So what is the reaction quotient? So the reaction quotient is given the symbol Q, and it's the exact same equation as the equilibrium constant. So we still have the products concentrations multiplied by each other raised to their coefficient powers, divided by the product of the reactants concentrations multiplied to their coefficient powers. But the difference is that it's not at equilibrium when we're talking about the reaction quotient. This is at a given moment. So if we know the concentrations at any given moment, we can plug them in this reaction quotient equation, which is the same equation as the equilibrium constant. But the reason we would do this is to compare where the reaction is at a moment compared to where it will be when it reaches equilibrium. And so if we compare the value of Q to the value of K, we can see if the reaction is proceeding towards the products or if the reaction is proceeding towards the reactants. So in other words, if the equilibrium has been disrupted, if according to Le Chatelier's principle, we've applied a stress to our reaction and the reaction is no longer at equilibrium, we can plug the concentrations that are known at a moment into the reaction quotient, solve for the reaction quotient, and compare that value to K. And so here is how we do that. If Q is greater than K, what that means is the numerator is too large. So we have too many products. And so the reaction is going to proceed towards the reactants in order to get Q down to K. In other words, the reaction will proceed until Q is equal to K. So if Q is greater than K, we have too many products, and the products are going to react with one another, and the reaction will proceed towards the reactants until Q is equal to K. So if Q is greater than K, the reaction proceeds towards the reactants. If we calculate Q and Q is less than K, then the reaction proceeds towards the products. And why is that? That's because now our denominator is too large. Q is less than K, that means our denominator is too large, and the denominator is the reactants. So if there's too many reactants, the reactants will react with each other and the reaction will proceed towards the products. Notice I'm using the word proceeds instead of shifts. We use the word shift when we're talking about a system at equilibrium and that equilibrium is disrupted and which direction the reaction will shift in order to achieve equilibrium again. Here we're talking about a reaction that's not at equilibrium, and the reaction is going to proceed in one direction or the other. So if Q is less than K, there are too many reactants, and the reactants will react and proceed towards the products to make more products and get Q back towards equilibrium so that Q equals K. So what if you calculate Q and Q is equal to K? we're at equilibrium, and the reaction will not proceed in either direction to achieve equilibrium because it's already at equilibrium. So the reaction quotient is simply a way for us to calculate that at any given moment, are there too many reactants, too many products, which direction will the reaction proceed in order to achieve equilibrium? And it's just a comparison between Q and K. We can also do this. I've done this for Kc, the equilibrium constant for concentrations, but we can also do this for Kp if you have gases. And remember, if you have gases, it's the pressure of the substances instead of the concentrations of the substances. Remember, for Kp, we use P instead of brackets because brackets mean concentration and molarity. P means pressure. So we can use the exact same calculation for Q for Kp as we do for Kc. We would just use pressures instead of concentrations. Hopefully that jogged your memory about what reaction quotient is. If you have any questions, as always, please feel free to ask me. I'll be happy to help out. Good luck in your studies. Bye-bye.